Hi, Algebra 2. Let's go ahead and take a look at the notes for today, section 6.3, which is binomial radical expressions. So I want to take us back on a little mental field trip to Algebra 1 when you learned how to multiply two binomials. Let's say x plus 2 times x minus 5. So how did we do that? We did the distributive property twice. So we took the x from the first binomial and distributed it to the second. So x times x and x times negative 5. And then came back with the 2 from the first binomial and distributed it. 2 times x and 2 times negative 5. So we have four partial products. We go ahead and simplify those products, x squared minus 5x plus 2x minus 10. And we have two like terms, negative 5x plus 2x. So out of our four partial products, two of them were like terms. So we combine those together, x squared minus 3x minus 10. So you remember doing the distributive property twice, what some of your teachers in Algebra 1 or middle school might have called FOIL. So if we deal with radical binomials, we're actually going to take the same approach. So let's look at this one. 1 plus square root 3 times 2 plus square root 5. Two binomials, we're going to do the distributive property twice. So I'm going to distribute the 1 times 2, 1 times square root 5, and then come back with the square root 3 times 2, and the square root 3 times square root 5. So simplifying, I get 2 plus square root 5. Now notice here, the 2 is an integer. It's not inside of a radical. So when I multiply those, the 2 is going to go outside the radical, 2 times the square root of 3. Conversely, with square root 3, square root 5, I've got the product property. So I multiply the radicands, 3 times 5 is 15, and it goes under a radical. So now we're going, well, when I was multiplying two binomials, I always had some like terms to combine. What happens here? Because I don't see variables. Okay, so can this expression be simplified further? And as it turns out, no. Just like we can only combine like terms when they have the same variable, same exponent, when we're trying to combine radicals, we can only do that when they have the same radical part. So here I have a square root 5 and a 2 times the square root of 3. Those don't have the same radicand. I can't combine those. And here's a square root of 15. So I can leave these as a sum. I just can't simplify. Only can add radicals when they have the same radical part. Really important when it comes to working through multiplying binomial radical expressions. So let's look at an example where we can combine. 5 times minus 4 square root 5 times negative 2 plus square root 5. So here's our distribution. 5 times negative 2, 5 times square root 5. And then we come back with negative 4 root 5 times negative 2, and negative 4 root 5 times root 5. So I rolled a couple things in together here. Let's explain. 5 times negative 2 is negative 10. That's pretty easy to see. 5 times square root 5, same situation we had before. We feel like we should be able to do something with the 5s, but we have an integer and then a square root 5. Not the same thing. So 5 times square root 5. Here, my integer negative 2 gets multiplied by the integer outside the radical. Negative 2 times negative 4 is 8 times the square root of 5. And then here, square root 5 times square root 5. So if I use the product property, that's square root of 25, which is just 5. Or I can think of it as squaring a square root. They undo each other. I get just the radicand. So negative 4 times 5 is negative 20. So negative 10 plus 5 square root 5 plus 8 square root 5 minus 20. Now I do have the same radical, like radical terms. So I can combine those. 5 turtles plus 8 turtles is 13 turtles. So 5 times square root 5 plus 8 times square root 5 is 13 times the square root of 5. And then my two constants, negative 10, negative 20, gives negative 30 plus 13 times square root 5. So here's one you can do on your own. If you want to go ahead and pause the video and check your work afterwards, do that. We have 5 plus 4 square root 3 and 3 plus square root 3. So 5 times 3, 5 times square root 3. then 4 square root 3 times 3, and then I have 4 square root 3 times square root 3. So let's simplify. 5 times 3 is 15. 5 times the square root of 3. Here I have 3 times 4. That's 12 times the square root of 3. And then here, square root of 3 times square root of 3 is 3 times 4 is 12. So 15 and 12 is 27, plus I have 5 and 12, 17 times the square root of 3. So let's look at a special case. We're multiplying what are called conjugates. The same terms, different signs. 4 plus square root 5, 4 minus square root 5. And if you were in class today, we did a warm-up where we did difference of squares. X plus 9, x minus 9. It's going to look really familiar. So 4 times 4, 4 times negative square root 5, square root 5 times 4, and then square root 5 times negative square root 5. When we simplify those, we get 4 times 4 is 16, negative 4 times square root 5, and positive 4 times square root 5. And then here's that case again. Square root 5 times square root 5 is just 5. In this case, negative. Look what happens in the middle here. I have two terms, same radical part, they're opposites. Negative 4 times square root 5, positive 4 times square root 5. They sum to 0. So I'm just left with the 16 minus 5. And then when I simplify that, I get 11. Let's practice another one. Again, you can pause the video here and come back and check your work if you'd like. So 6 times 6. So if you take a look at the work, 36 minus 2 gives 34, and then these two middle terms are opposites. They're going to sum to 0. That eliminates the radical term, and I'm left with just 34. So let's consider another case. What if we have a binomial radical in the denominator of a fraction? Well, we know that we can't leave a radical in the denominator of a fraction, so we have to rationalize. But we can't just multiply times the radical part, because that will still leave me with a radical when I multiply it times an integer. But we've seen that multiplying by a conjugate eliminates the radical term. So we're going to multiply the numerator and denominator both by the conjugate to eliminate the radical. So let's see what that looks like. We're going to simplify 4 over 2 minus square root 3. So the conjugate of 2 minus square root 3 is 2 plus square root 3. So I'm going to multiply times that in the numerator and in the denominator. So the numerator, pretty straightforward, 4 times, parentheses, 2 plus square root 3. The denominator, 2 times 2 is 4. My middle two terms are going to eliminate because they're opposites. And then square root 3 times square root 3. So that's 3. 4 minus 3 is 1. So my denominator now no longer has a radical in it. In fact, it's 1, so I'm not going to write it at all. So I'm left with 4 times the quantity, 2 plus square root 3. Or if you wanted to distribute that, 8 plus 4 times square root 3. So again, you try one. You can pause the video here and come back and check your work if you wish. All right, so here's how this one played out. Here's your middle two terms going to 0. 9 minus 6 is 3. So 5 times 3 plus square root 6 over 3. All right, so as you finish up, go ahead and let me know how you feel about multiplying binomial radical expressions. Do you feel great? Understood everything? Do you maybe got a couple wrong as we practice, but do you understand where those mistakes were? Do you feel a little bit like I need a little bit more help here before I feel confident enough to take a quiz, or I'm just flat struggling and I want to come in office hours on Friday?